Good afternoon, my name is Paul Jeffrey. I am the process leader in the paint shop at Rolls-Royce Motor Company. Today, the topic I would like to be talking about is a work measurement study, a hypothetical work study in the paint shop of increasing our units per day from 20 painted car bodies to 25 car bodies. The layout at the moment consists of four main process areas. One of them is the application area. The application area runs in a combination between robot application, which is automation, and also we have 6 spray associates that every time a car body comes into one of the spray booths, they both go into the spray booth, either side, and they spray the interior parts of the body shell. From that point of view, at this moment in time, historically, what we have done is carried out short circles and also spaghetti diagrams to have an understanding of the time taken within their process. Within that process, there is a Gemba standard. Now, the Gemba standard informs the associate on that particular process what needs to be carried out. With that as well, there's also, we look at a format of retrieving data, because at this moment in time we are producing 20 units per day. From a customer demand, we're looking to increase that by 5 units a day, which is 25. Now, what we put in, we track layers at this moment in time. So for every car body that comes into our application area, which I showed you just in the blue highlighted area, we track how many layers we should be doing every hour. If we lose that hour, what are the reasons? So what we're looking at is problem solving, in as much as the things that are stopping us from actually producing those layers. They could either be machine, man, motion, in as much as breakdowns. From the information that we receive, this gets taken to our process supporters, and what they do is either the just do, problem solving, or they carry out a thing called VPS small, which uses the problem solving of DMAIC, in as much as the way to problem solve in line with our VPS wheel, which shows with regards to our core values of our company. So just to recap, with regards to the present state at this moment in time, we carry out 20 cars a day we produce through the application area. The current studies and historical studies, we've used time and motion work studies, process confirmations, spaghetti diagrams, and carry out short circles to assess volume of traffic and distance associate walk. And we also, as I said, the last statement was tracking painted layers to build plan, including the reasons why we haven't actually been able to sometimes meet that amount of layers. So, moving on from that, from the hypothetical layout, what I did was look at what we've got, and bearing in mind from when the Rolls-Royce footprint was first initiated, the plant was only going to produce 5 units a day. So to go to that 20 was stretching us. To go to a further 25, we had to start looking out the box, have an understanding of what our constraints are and what other things we could actually do to think about increasing the volume. So there were 3 scenarios. The 3 scenarios were to have the painted bodies painted off-site in the UK somewhere, or in Germany where the body's made, but only do the monos out there. And then the third one, which I will be discussing with regards to fully automation. So, fully automation would mean installing a further 6 robots, and these would be handling robots which would open the doors, the bonnets and the boot lids, allowing the existing robots to go in and spray the internals of the body, thus alleviating the need for actually associates to go in and spray. From a health and safety point of view, because from all these chalk circles that we do, we have an understanding of not only the movements they're doing, twisting, bending, lifting, and working at somewhat heights when they have to go onto the conveyors to actually spray the interior of a engine bay. So from the outset, the new requirement of 25 units per day, we assessed historical information with regards to what the robots were painting, taking away the associate spraying time, and then running a simulation plan by a company called Simplan, who we will give our system over to them with all our KPIs, our time studies, and then what they would do is replicate it and also the timing it would take to simulate the doors, bonnets and boots opening for the interior spraying of the cars. With this information, the positives came back in as much as that in a simulation, it was proved that we could not only meet the 25 units per day on a 2-shift, that it was future-proof, or could be future-proof, that if we were to run a 3rd shift on night shift, we could produce a further 6 bodies and also allow the time for TPMs and planned maintenance. So from that point of view, it was encouraging. Positives is the improvements would lead to meeting the customer's expectations. It would eradicate the health and safety issues which were from the associates going into the areas to spray the cars. From process, the robots would be more efficient. However, the expenditure of the robots is extremely expensive as a negative. With regards to the savings that will not only meet the customer's process time, but below 13 minutes, but also this would lead on to us being able to fulfil the customer need. From there on, what we started to look at is to see whether or not indeed we could see whether or not there are other factors within installing these robots and robot handlers to see whether or not indeed there any other variables that we could take away. One of the variables was that when the skid came into the booth area, it needed to sit in a certain position for the paint to be applied without any free movement. This came about in as much as what we were looking at to see if there was a system that would lock the skid in. So as the body came in, it would hit a laser point. Once the laser point would meet, then it would meet the laser point, and then the skid itself would be clamped in a certain position so that the repeatability of the robot programs could continue. Over and above that.
That's very good. I've got a couple of questions, and mainly around about ergonomics, I would think. So,
yes.
Taking out the consideration that you would move to robots,
yes.
What were the ergonomic issues that you were seeing with the associates in the original situation? You mentioned opening doors, bending.
Yes, so they had their PPE. The associates would first and foremost have PPE, their personal protection equipment. That on it in itself gave limitations of visual awareness. Also, they would be carrying their airlines and paint lines, which would clip into their belts. Once they're in the cell to start spraying, the body itself is nearly a metre up in the air. So from that point of view, it's opening up doors at a height, stepping onto a conveyor to get onto so that they can actually spray the inside of the cars. So there's a lot of stepping, a lot of twisting, stepping up onto steps. The floor itself, although it's regularly cleaned, by virtue of the same cell is being used to spray with the robots, the paint, the floors were sticky. So there was trip hazards, there was twisting, bending, yes. And
So even if robots didn't exist, the ergonomic issues here may well have been pointing you to look for an improved methodology anyway.
I think certainly the product is built on being hand built in Goodwood. That was the premise to begin with.
Yeah.
So from that point of view, that all the health and safety risk assessments that we've done, the chalk circles, aligned with spaghetti diagrams as well, this was the most simplest footpath to actually spraying. Prior to this, there was a larger amount worth of movement. We've reduced it massively. Going on to the 25 units per day, the hypothetical 25 units per day, that would take us completely away from the health and safety implications of sprayers going in. I think naturally it would have gone in the end, but there would be no plan to, if the demand wasn't to come about.
So are there different ergonomic issues in terms of maybe the operators having to work in proximity of the robots, or the environments that are now available for those people to work in?
So if this was to be put in place, although we would not have the sprayers, what we are needing to do is upskill them so that they would become the robot operators. So from a robot operator point of view, they would be doing the TPMs, the total preventive maintenance. There's also overspray that the robots, increased overspray, which would land on the robots. So instead of it actually being the robots needing to be cleaned a lot of times when cleaning the robot, socks are put onto the arms of them. So they would need to be taken off, they would need to be refreshed. So instead of 6 people within that team, it would be reduced down to 2. From the ergonomic point of view of a clean down and preventive maintenance, there is still the ergonomics of bending and twisting, but the risk is hugely reduced because you're not dealing with a live product that's coming in. That's being completely eradicated. What you're dealing with is something that is a fixed item in a fixed place that you are working around. Although that would mean and facilitate to go on steps, the risk assessment would be taken out to begin with our health and safety department to ascertain whether or not it is what associated risks, whether we need working in height certificates and some sort of way of restraining the person from falling.
And so you've got this environment, you envisage this environment which is mainly robots within that environment.
That's exactly right, yes.
So is that then self-contained? It doesn't affect in any way the rest of the manufacturing facility in terms of noise, energy consumption, emissions
from
the robots and that control mechanism?
It's totally isolated, it has to be. It's a very clinical area. From the environmental impact, there will be less wastage. The robots will spray the same commodity at the right time and at the right place. Where the human intervention, there is always that area where they'll either put too much or too little on, and if they put either or either, one can cause not enough paint, so it could come back for repair, and if there's too much paint, it can cause runs and bottles. So from the amounts that's usage in as paint, in as much as the paint, there will be a lot less. And also there is the associated hardware that the sprayers use, whether it be masks, air lines, paint lines and spray guns and PPE. So there is reduced, but as I said to you before, there's a massive outlay that is attributed to robots.
Okay, very clear. Thank you very much.
Thank you.